Hi everyone, welcome back. In this video, we're going to go over a couple of quick examples of how we can use our double and half angle formulas to help solve problems. Okay, so we're starting off with example 1 from our textbook, which is from page 462. In this example, we're given two pieces of information that sine of alpha is equal to 3/5. We're also told that, sine of theta is equal to 3/5. We're also told that theta is in between pi and 2 pi, which if we think about the unit circle, tells us that we are in quadrant 2. So between pi and pi over 2, we're going to be in this quadrant here. So we're in quadrant 2. Quadrant 2 has positive values for sine. So sine is positive, which makes sense because we're told that sine is positive 3/5. We know that the cosine value is going to be negative in quadrant 2. So that's the important pieces of information we can get from that angle restriction. So we're being asked to find sine of 2 theta to start off. And what we can do is just start off with writing our double angle formula down. So sine of 2 theta we know is equal to 2 sine theta cosine theta. Okay, so to rewrite this, we need to find what sine of theta and cosine of theta is. Well, we know sine of theta, we were given it. To find cosine of theta, we can use our Pythagorean identity and use sine of theta to help us out. So we know that cosine squared theta equals 1 minus sine squared theta. Cosine of theta then is equal to plus or minus the square root of 1 minus, and then sine squared, we have 3/5 squared. Sine of theta squared is 3/5 squared. And we were told by the quadrant that cosine is negative, so we're putting our negative sign, the negative square root, in front of here. We continue solving. We have negative square root of 1 minus 9/25, which finally gives us negative square root of 16/25. So cosine of theta is equal to negative 4/5. Great, so we have our sine value, we have our cosine value. We can plug both of those in to our formula, our double angle formula that we have here. And we end up with sine of 2 theta is equal to 2 times sine of theta is 3/5 times cosine of theta is negative 4/5. If we multiply this all out, we end up with negative 2 times 3 is 6, times 4 is 24, and 5 times 5 is 25. So negative 24/25. That's what sine of 2 theta is equal to. Awesome. So we used our double angle formula, and then we use what we know about the unit circle to find the sine and cosine values, plug those in. Next, we're finding cosine of 2 theta. And as you can see, I've written down below our double angle formula. So we've already started off. Thankfully, we're using the same cosine and sine values that we found above. So our sine value here, our cosine value here. So on that right side, I'm going to replace those. So cosine squared, for cosine, we have negative 4/5 squared, minus sine is 3/5 squared. On the left, we end up with 16/25. Then we're subtracting 9/25, which we simplify gives us 7/25. So for this example, 7/25 is our answer for cosine of 2 theta. And there we go. Those are our two examples of how we can use double angle formulas to find sine of 2 theta, cosine of 2 theta. Next, I want to take a look at one more example, which is example 5 from our textbook, page 465. For this example, we're just going to look at the first part. We're being asked to find cosine of 15 degrees. So we don't know what this is offhand, but thankfully we do know that 15 degrees is half of 30 degrees. 30 degrees over 2 equals 15 degrees. So what we can do is rewrite this as cosine of 30 degrees over 2, and then use our half angle formula to help us out. As a reminder, I'll write it up here. Cosine of alpha over 2 is equal to plus or minus square root of 1 plus cosine alpha over 2. Okay, great. So cosine of 30 degrees over 2 is equal to plus or minus square root of 1 plus cosine of alpha, which I'll just write out right now. In this case, alpha is 30 degrees. So we have 30 degrees in this numerator. So cosine of 30 degrees all over 2. Okay, so the first thing I want to look at is the sign in front here, the plus or minus. We know that, I can just rewrite this as 15 degrees on the left. We know that we are in the first quadrant, 15 degrees, which means cosine is positive. So we're just looking at the positive square root. So positive, and then we can put into the numerator what we know, which is cosine of 30 degrees. Cosine of 30 degrees is root 3 over 2. All over 2. Okay, so simplifying this a little bit, one way to simplify is 1/2 plus root 3 over, we can multiply the denominators to get root 3 over 4. And then we can combine these by multiplying by 2 for our first term in the numerator and denominator. We end up with 2 plus square root of 3 all over 4. Our last step is we can take the square root of the denominator, numerator and denominator separately. So if we do the denominator, we get square root of 4, which is 2, which tells us that cosine of 15 degrees is equal to the square root of 2 plus root 3 all over 2. And that's it. That is cosine of 15 degrees, how we can write it using values that we know. We do have a square root under a square root, which is fine. It looks a little weird, but there's no rules against that. We can just leave it as that. Okay, so that's an example of how we can use our half angle formulas to solve problems. For example, finding angles that are half of known angles from the unit circle.